Alright, in this video we're going to look at the concept of increasing and decreasing functions. So I've drawn a function here. Call this function f of x. So increasing and decreasing functions it's a fairly straightforward concept. Increasing function basically means it's going up from left to right. So from a to b, it would be increasing. So increasing from A to B. Decreasing would mean going down from left to right. So from B to C, it's decreasing. And then after C, it again starts going up. So increasing after C. Okay. So that's, it's a fairly straightforward concept, I would say. Now we'll often talk about intervals of increase, decrease. So in those cases, we'd be looking at, for which values of x is the function increasing. So let's call these values point B, the x value will be B, this one will be C. Okay, so we would say the intervals of increase so that means which values of x is this function increasing. You can see if it's increasing from A to B, but point A to B, then we'd say from little a to little b, those values of x, it's increasing. So it's increasing on the interval from A to B, and also after C. So from C up, so we would go from C, I guess, to infinity. The arrow indicates it keeps going. One thing just to be sort of aware of is it increasing at the point B? So point B is where it sort of changes from increasing to decreasing, right? It's no longer increasing at B, it's turning around. Our textbook always has intervals of increase as open brackets, so it has to stop increasing at its sort of endpoint. You will see it written differently, and depending on how we formally define it, it would make sense to include sort of that endpoint. But we'll just go by what our book does. So we'll say intervals of increase and decrease are always going to be open intervals because it would stop increasing at that sort of endpoint. And the intervals of decrease, so from this one would be from B to C. Of course, this point B and C, as we pointed out, that's kind of our boundary point where it goes from increasing to decreasing. We do give that a special name. So we're going to call those turning points. So turning points, or a turning point, will be defined as a point where the function changes from increasing to decreasing. Or vice versa. So, or decreasing to increasing. Vice versa. Okay, so in this example, B would be one turning point. So if you wanted to write the coordinates of B, the x value is B, and since the function is f, the y value would be f at B, and C, f at C. So therefore, B, f at B, and C, f at C are turning points. So those are points where we switch from increasing and then start going down to decreasing, and then from decreasing start going up to increasing. So we sort of an informal definition of increasing, right? Increasing means up from left to right, and decreasing means down to left from left to right. I'm going to quickly write the formal definition down. Okay, so here's our formal definition of increasing function and decreasing function. So a function f is increasing on the interval a to b if f at x1 is less than f at x2 whenever x1 is less than x2 in that interval ab. So that probably requires a little bit of explanation. All this is really saying is that the function is going up from left to right. It's the same as our intuitive definition, but let's just look at our picture to see what this means. So what it's saying is that whenever x1 is less than x2, so let's look at this interval from a to b. So x1 would be here, and x2 would be here, right? x1 had to be less than x2. Okay? So x1 was less than x2, then that means that f at x1 is less than f at x2. Well, f at x1 would be the point on the curve here, right? This is f at x1. And f at x2 would be this point. So notice that x1 is smaller than x2, and f at x1 is smaller than f at x2. So basically that's all the definition was saying, that if this point is less than this point, so to the left of it, then the height on the graph must be smaller than the height of the other point on the graph. So basically all it was saying is that you're going up, right? All this was saying is that as you go from left to right, this value would be smaller than this value. So you get bigger as you go from left to right. That's all this definition is saying. And then the same for decreasing. A function f is decreasing on the interval b to c if f at x1 is bigger than f at x2 when x1 is less than x2. So now let's look at the interval b to c. So b to c would be from here to here. So here x1 is going to be here, different x1 and x2. So x1 is less than x2, so you're going from left to right. And we're saying that here's f at x1, and here's f at x2, the height of these two. Right? So this is f at x1, this is f at x2. So f at x1 is bigger than f at x2, which is what our definition said. F at x1 is bigger than f at x2, meaning you're going down. Right here, this would mean you're going down from x1 to x2. So as you go from left to right, you go down. So that's what our definition of decreasing function is. So the same as our intuitive definition. So this is worth writing down. It's our sort of formal definition of increasing and decreasing, but it fits our intuitive definition of increasing means going up from left to right, and decreasing means going down from left to right. So let's just look at one real example. So consider the function f at x equals, we'll go with a very simple function, x squared. So we want to figure out where is this function increasing and decreasing. Right now, basically the only method we have for determining this is to look at the graph. When we get into calculus, we will learn sort of more analytic techniques, so how to figure out from the equation if a function is where it is increasing and decreasing. But right now, all we can do is look at the graph. So we know that f at x squared looks like this. It's a parabola opening up with a vertex at the origin. So our interval of increase, so there's only one interval of increase because it's only increasing on one interval, and that would be from 0 and up. So our interval of increase would be from 0 to infinity. And remember, as I said, 0 is kind of where it changes from decreasing to increasing. So sometimes you'd see that written, you would include 0 in the interval of increase, but for us in our book, so we'll follow that convention this year. We'll say it's always an open interval. The interval of decrease, well, that would be, this is where we're going down from left to right. So it would be from negative infinity to 0. And again, open interval. And if we wanted to talk about the turning point would be where do we change from increasing to decreasing or decreasing to increasing. So sort of where's that boundary point, which would be right here at x equals 0. So the point here is 0, 0. So our turning point is 0, 0. Notice turning point means the point, not just the x value. So our turning point is the point 0, 0. So there's a real function that we're familiar with, talk about its intervals of increase and decrease and its turning point. Right now, the only way we can do that is to look at the graph.